Alrighty then. I will be showing you guys how to set up Windows ISS. I am using GNS3, and let's get started once I get my screen shared. Okay, so right now I have a topology with two endpoints, and I'm gonna drag this Windows server. This is a 2016 Windows server. So let's go ahead and connect it. Start it up and go to console. Don't worry, I'll possibly just fast forward this part. Usually Windows Server takes forever to, you know, add all, or not add all. Basically takes a while to set up. Okay, we'll be prompt for the Windows setup. Um, I chose English, English, and US. Let's keep it as default. And it's going to give us a prompt, install now. Okay, we're gonna give we're gonna get offered four options. The Windows Server 2016 Standard Edition, the Desktop Edition, and these are the enterprises. The Standard Edition or Standard Evaluation is just a CLI. We're here to use a GUI. So we'll go ahead and select the Windows 2016 Standard Evaluation Desktop Experience. And we're gonna have to read the license. Go ahead and hit accept, hit next. And we're going to be prompt with the installation question. Do you want to upgrade or custom? We're going to go ahead and click custom, allocate drive 0, hit next. And after all that, it should be downloading. So as of right now, we're just setting a Windows server. This is going to take a while. Don't worry, I should be able to fast forward. If not, just skip it, skip this portion. Go ahead, play some music in the background, see if anything goes. Oh, damn, still loading. We're almost there. All right, there we go. Finally finished installing. Um, there's gonna be a lot of us like waiting around, so there's no hurry up. And wait, and also I'm using DNS3, which is just making it slow. In addition, I'm using a laptop, which is not great. Should just use like a my other computer. Oh, there you go. So it's gonna restart, and once it restarts, it's gonna give us some questions. Here you go. Don't worry, this one's faster. Don't worry, it's just restarting. Here you go. Okay, it's gonna give us a screen that's gonna ask for a password. Go ahead and enter your password. Hopefully I remember it, because that'll be bad if I forget the tutorial. Okay, we're gonna get placed into the window screen. For GNS3, um, you can't input Control Alt Delete. So luckily they gave us the option right on top. Go ahead and click this, Control Alt Delete, and enter your password that you just entered. Honestly, you could do this with your regular laptop as long as it has Windows. I was able to deal with my old Lenovo G3, and I mean, it worked just fine. Okay, give it a minute. Since we're using Windows Server, it should pop up Server Manager. Uh, all right, if it's not going to open, oh, there it is. There you go. Going to open Server Manager. All right, first rule of business. We're going to go ahead and select Manage. We're going to add roles and features. Well, let me wait a bit. There I go. I guess it's still downloaded. Oh, there. Come on. Now. Okay. So it's just gonna give us. We're basically gonna install um, Windows ISS. So before you begin, you hit Next. You're gonna select Role Base. This one I could. Let me see if I could change the name. No, I can't. So this is the name of our Windows system. Could have possibly changed it, but do not forget this. Next thing we do is hit Next. Okay, this is important. So in the roles, we're gonna have to scroll all down to web servers ISS. Go ahead and click it. So what's gonna install is ISS. Okay. I mean, if you also want to, you can install other things like a DHCP server. I believe there's a DNS server right here, and yeah, remote desktop service. But as of right now, we're doing a web server. Okay. Let me double check before I hit OK. All right, it's all good. Let's go ahead and hit next. Basically, description of what you're going to be installing, roles and service if you want to add anything else. But right now, we're going to leave it at default. All right. After you get all, after you read all this, go ahead and click install. Now, this is going to be painful because it's another waiting. Or waiting, let's see if we have internet access. Yep. Oh well. Uh, oh, didn't notice that it finished. All right. And once it's finished installing, go ahead and hit close. We're gonna go to the window, power, restart. Hit continue. Every time you install something, you have to restart it. I learned the hard way um, during my time in the army. I had to do this multiple times, and the computers are pretty slow. Worse than this. Go ahead and put your password in. Give it a minute. Okay. Don't worry. As long as ISS is up, or it's green, should be good. Although right now we're gonna go to our Internet Explorer. Ooh, this thing is ancient. Okay. Go ahead and put localhost And there's your ISS website. So right now it's just in the default. You could add files to it. I mean, I was able to make an FTP server as well as, make a little website. But right now, I'm just going to be showing you how to set up HTTPS. So going back to our server manager, go ahead and click Tools. You're going to go to Internet Information Service Manager, ISS Manager. Okay, let's go ahead and make this bigger. We're going to go ahead and click this down arrow. Well, it's going to be down in a bit. Let me just open them all. So right there is our default website. But it's HTTPS, you need a certificate. But since I don't want to waste money on buying a certificate, you can always self-sign a certificate. So go ahead and click Server Certificate, create self-signed certificate. Okay, so it's gonna ask you what do you want to name it. So I'm gonna put, what should I add? My final project. Hit OK. All right. So you have made a self-signed certificate. Expired 2026. The hash, basically, so personal. Next thing we're gonna go is click our default website, right click, and edit binding. So we're gonna select add. We're gonna change it to HTTPS. Obviously, I'm not gonna assign it. And then it's gonna ask for SSL certificate. We're gonna go ahead and select the certificate we made, our self-signed certificate. Select OK. And then close this. All right. So remember when I first opened, um, what's it called? Internet Explorer? I was sent to HTTP, which is unencrypted. So I can show you right here. Easy. And it also shows you right here, HTTP. Go ahead and close these. All right. So what we have done is we created HTTPS. Go ahead and click on browse HTTP or HTTPS. It'll take a little bit. Ah, there it is. It's gonna ask you, there's a problem with the website. Since I self-signed it, it's gonna consider like untrusted. But we made the certificate. We know it's, safe. But in the real world, I wouldn't even go to any website like this. But we're gonna go ahead and click continue. Just another warning. And there you go. We have made a HTTPS. Awesome. Go ahead and click on this. Details. There's our name of the computer. There's a computer. So basically self-sign. All right. Hopefully that was helpful to make an HTTPS server or website. Let's go ahead and do Apache. All right. Instead of this, possibly it's just my camera's making it slow. All right, guys. I'm gonna be showing you how to set up an Apache server in GNS3. First thing we're gonna do, have a topology like this. Now, if you're in my previous video, I set up Windows Server as well as Windows ISS, as that took a while. And in addition, I also set up that default web page as a HTTPS website, which I use self-signed certificates. And now I'm just going to be showing you how to make a Apache 2 server. All right, go ahead and drag your Ubuntu desktop. I'm going to call this Apache to make it easier for me. Connect to your switch. Start it up. Hit console. Go ahead and sign in your Ubuntu machine. If you don't know the password, is literally osbox.org word by word. I really hope that it's not going too slow. Oh, better than last time. Let me give it a minute so I can process. Okay, that's enough. We're gonna go ahead and open terminal. Okay, first thing we're gonna do is update the repository. So sudo apt uh, not install, update. Enter. It's gonna ask you for your password. Go ahead and put your password in, hit enter. So right now I'm trying to get the most up to date. So hopefully I don't get any issues down the line. Don't upgrade. Let's cancel that. Okay. That was just for my Ubuntu box. Don't worry about it. Until we, now we wait till it finish. Right now it's still going. Oh, there you go. Updating. Okay, awesome. Go ahead and clear that. Next, we're gonna do is install the Apache server. So first thing we're gonna do is the sudo apt install 2L Apache dos. Press Y, hit enter. It's just taking a while. There you go. Let's go ahead and clear that. We're going to go ahead and open Firefox. Give it a minute. Previously, Firefox did not want to open. I assume because I tried opening a lot of Firefox tabs. So we gotta be patient with these machines, especially in DNS3. Until it's not working. It looked like it was. I'm gonna give it a minute. Hmm. Awesome. Patience is the virtue. Ugh, just wait. I'm just gonna close this. Okay. Similar to what I said, go to your web browser and put in local host. Hit enter, and I should be going to the Apache server in this host. Well, in this box. If this comes up, just hit ignore or do not update. All right, so there's my default page. Now, if you ever want to change how the website looks, you're gonna have to go to your terminal and submit or type in this. I could show you. Copy. First CD. Paste. Oops. I'm gonna use Nano. I forgot it's HTML. There you go. So this is the code that's running in the background. Now, if you want to change it, by all means. Let's see. I could change it. Oh, look. See? I know a little bit of HTML. So let's just make it simple. Oh, forgot this nano. I'm gonna change it works. So I'm gonna be changing this right here. Just to prove that I'm in charge of this website. Go ahead and exit, save your modify, enter. Oops, oh, forgot. Okay, so when you're gonna edit this, you must be root privileges. So nano/form HTML/www/index .html. Oops. Oh no, what did I do? I swear I thought I used the right one. Okay, this better work. Oh, I see what I did wrong. It's supposed to be www/html. Okay. All right. Let's go ahead and change this right here. I'm just gonna show you that you could edit the website by messing with the source code. So let's see, CPSC. This is my server now. Smiley face. See. Go ahead. Look at like CSS. It's HTML. Oh, whatever. Just save it. Okay. Control X and save right there. Now you should see if it changed. I was able to change the header right here, and I misspelled it. Well, at least now I know how to change the title. If that wasn't it. Mm, there it is. Okay. Mm, add there. I'll put my name. I can spell my name, right? Okay. Same as last time. Control X, save, save it to that file, and we are gonna refresh it. There we go. And that's how you make an Apache server. You can do whatever you like with this. Obviously, I could have deleted it and start with the blank. But in this case, I didn't want to do that because I don't know much HTML or anything much with the web. All right. In my next recording, I'll be setting up Node.js. Mhm. Okay, so we just finished setting up a Apache server. So let's go ahead and double check. Now bear with me. This one's not too bad. We're going to be setting up an HTTPS server or HTTPS in our local host. And since I got to turn my computer in today, luckily I was able to get it working by night. Let's see if it works. Localhost. Mm-hmm. And there you go. Now if we try putting, let's say HTTPS, like a normal one, it won't work. It's going to give me an error. All right. To set it up, we're going to have to modify a couple things in our website. Let's go ahead and close this. Let's go to terminal. Sudo UFW allow, and then we're going to put Apache, spell it right, Apache full, close, enter. Gonna ask for my password, OS. Oh, spelled it wrong already. Okay, there you go. I updated my roles. I believe this is for my local firewall. Next, next I'm gonna add this command, sudo a2en mod SSL. Awesome. Next, we're gonna add this one. We're gonna restart our Apache server. Enter your code. Okay, so next thing we're gonna do is we're gonna use OpenSSL to create a key and a certificate, which will be this following command: sudo OpenSSL req dot x509 dot node dot date. Yeah, 365. That's how many days I want it valid for. Key dot key out dot etc. This is where I'm going to be putting the key. My SSL folder dot private, and then Apache dot self sign. I'm going to put this as one. That key dot out. This is where I'm going to put for my cert, the directory. So etc SSL slash Apache dot self sign one. Keep it. I try to keep it consistent with the key. CRT. And let's double check if everything looks right. So sudo OpenSSL rec using this one, nodes, days. We're making a new key. Oh, ooh, there. See, it's good to double check. So after days and or after 365, we're gonna put RSA and then two or we're gonna put colon 248 or 2048. And then, oops, I'm sorry. It wasn't after 365. It was after new key. New key RSA 248. Then the key out. Uh, the key out, and then we're putting in our Etsy server. Etsy SSL private Apache Sun 1. That out. All right, if everything's good, yep. It's gonna ask us for information for our certificate. So what we're gonna add is, you know, the US and put California, uh, our city, like Fullerton, organization name. Mm, I mean, I'm just gonna put CSUF. Just again. Mm, corporate common name. I'm just gonna put. I could have put a local host, but I'm just gonna put that. Email address. I don't care. All right. Next thing. So what we have just done here, we put in our information for a certificate, which we just made. Next thing we're gonna do, clear this, sudo, get it, and it should open a GUI tab. So what we're gonna do is go ahead and hit open, other documents, and we're gonna go to the Etsy Apache 2 file. So go over here, other location, computer. There it is. Mm. Oh, here it is. I'm just blind today. I mean, it's first thing in the morning. Okay, we're gonna open both of these files. Awesome. So right here we have our port 80 for our local host. What we're gonna do is make one for our our port 443, which we're gonna do right now. So we're gonna copy, and right below it, we're gonna paste it. Okay, so you're gonna have two of them now, but in the one you just paste, we're gonna change this right here, port 80 to 443. Just to know that it's this port. And what we're gonna do, we're gonna add right below, let me see, scroll down. Right here, right below document root, we're gonna add this new line. So SSL engine, oops, let's keep it consistent. On, we're gonna put SSL certificate file, that's Etsy slash SSL cert Apache dot cell sign one dot cert. Basically where you put your certification. And make sure you spell it correct because multiple hours were spent trying to troubleshoot, and it was just, one misspelled word. You gotta love Linux. So right now we're putting in the key for our website. Apache. So I all right. After all that is done, double check. SSL engine on. It looks good. Let's go ahead and save it. Oh, sorry, it's right here. Save it right here. Now this one's just to prove that it exists, which we won't need right now. So let's go ahead. All right. So next thing we're gonna do, I'm gonna open. Oh, go ahead and close it actually. Okay, clear. So the next command is gonna be sudo apache 2 control config test. We're gonna see if it's actually working. And that's why we check it. Let's see, sudo config test, line 47. Okay. Okay, I'll go ahead and open it. 00, line 47. Line 47. Hmm. Let's go ahead and see the history. Let's see. Maybe I could just figure it out like this. SSL engine on, certificate file, etc, SSL, certs. Oh my God. So right here, I put the wrong directory. See, something so small. Okay, now it should be able to work. Save it, close it. Let's go ahead and config test it. Hmm. Did it not save it? Shit. Let's double check. Mhm. Actually, I could just check in the directory here. So much easier. Go to other location, computer, Etsy. It was SSL. Where are you? Cert. Oh, maybe that's what's the issue. So I'm trying to get a random one. In reality, it's right there. See, I do not see it here. Okay. Let's go ahead and go back to SSL. Let's go ahead and drag that to the directory. Come on. Oh well, I'll just edit it from here. At least I know it's just an SSL. So, okay. There we go. So the issue here is my certificate was not, or where I was trying to show where my certificate is, was not in the right location. It's just a simple either move it to that or change the directory to your certificate. Okay, so when that works, let's go ahead and reload our Apache server. So we're going to put sudo system control reload Apache 2. And we got to spell it correctly. Okay, after that's done, let's go ahead and go back to our localhost. Okay, there you go. Let's go to our, that's right there. See which one's this one. Okay, so this is just our normal HTTP. Let's go ahead and add HTTPS. And if you give me a warning, this is good for me because that's how I know that I have a certificate in it. This is normal for all browsers. Basically, since I'm self-signing my own certificate, it's gonna display this, basically saying that I'm not trusted. But we're gonna set the risk and continue. All right then, and that's how you make your HTTPS server. Let's go ahead and check our certificate, our information. Okay, since I just made this, boom, there you go. See, this is the RSA SHA-256. Everything looks good. Alrighty then. Thank you for watching. Our next will be setting up Node and as well as setting up HTTPS with Node.js. With that one, we're gonna need Visual Studio Code. So thank you for watching. Alrighty, hello everyone. Hopefully you can hear me. Test, test, test. Let me double check if I can hear. Okay, awesome. All right, hello. Today we're going to be setting up a HTTPS server for Node.js. All right. Um, First thing we're going to have to do is go in our lint box, open our terminal, go to sudo apt install Node.js. Ensure everything's up to date. See, my Node.js is already updated, as well as update sudo apt install npm, which is going to be very helpful later on. Well, you're going to have to use it. Then I'm going to have to create a new directory. Let's see. Let's make. Let me see what directory I got. Okay. Let's create a directory called HTTP S server. Okay. Go ahead, ls. Okay, let's go into that new one, HTTPS server. Oops. Okay. So once we're there, um we're gonna have to make a, let's say, a package.json file, which the command is npm init. Okay. So it's gonna ask you package name. Just put bulletin. I spell it right. There we go. Yeah, sure. Oh, Sure. 1.1, that's fine. This is all fine. You could add if you like, but you can always change it into the package.json file. But for this tutorial, we're not going to do that. All right. Once we got that, let's create create a new file. Not nano. Um, our index.js. Make sure it's open. Good. And we're going to go ahead and work on what you call it? VS Code. Let's see. All right, let me pause the recording and see what's going on with. Okay, I'm back. There was just an issue with VS Code. It wasn't opening in time. It was just taking too long. All right, once we're in VS Code, let's open this file. Okay, we named it HTTPS server. Go ahead and open it. Oh, sorry, it's yeah, open. Taking too long. See what I mean? Let's see. Okay, so right now I have my index file and my package.json. Go ahead and edit my package.json. Let's add whenever a script's gonna run, let's add this. Believe is start. Oh, I'm fairly new to JavaScript, so bear with me. Do dev. What was the rest of it? I freaking. Okay, where was I? Okay, start.dev. No, start colon dev. Okay, and then colon. Then we're gonna put node dot index.js. Honestly, you don't have to do this. It's just easier for me. Or actually, just keep it as just um just follow this. Makes it easier. Okay. And on our index file, we're gonna test if we could get an HTTP server first. Okay, let's go to our text editor. Right now I have the code for HTTP. Let's see, where is it? It just makes it easier to, here it is. Actually, let's go ahead, copy this. I guess that's not what it's supposed to be. Let's go ahead and paste it. Um, let me, this is HTTP. This is the code we're gonna need for HTTPS, but we're gonna test HTTP. So there, we're gonna make everything HTTP. How do you comment out JavaScript? Okay, same as C++. Content header. Okay, go ahead and remove this. And change this to that. And we're going to be listening to port 80. Okay, let's go ahead and run that. Let's see. Let's go ahead and go to our local host. Or I could just put npm. All right. Give me a second. Mm. Oh, it's npm run start that dev. Okay, and it's running. That's how you know your Node.js is running. It says right there, Node.js. So let's go to our Firefox. Any day. Mhm. Okay, let's go to our local host, 8080. Let's make sure it's not going to, yeah, there you go. There you go. Hello, my final project. Awesome. Okay, so it runs. I shouldn't have closed it, but oh well. Um, Now we're gonna have to get started with the keys. Now with the keys, there's three parts. When making the key, when making I believe a private key to sign. Um, but let me show you once I get it going. Mhm. All right, first start removing this. Let's remove the comment. Do this. Options. There. Let's save it. Okay. Awesome. Let's go ahead and generate our keys. Okay. Sorry, this thing is just so slow. Go ahead and close this. Clear. Go to open SSL, and then we're gonna generate RSA dot out. Then we're gonna use key dot pem as our name for a key. Awesome. Our key is made. Now let's go ahead and make a CSR dot pem. So open SSL require or rec new that key.pem dot out, and then we're going to use the csr.pem. Double check. I mean, I did this like 5 times already, so pretty confident in my work. And plus, I don't have to do so much text editing. I already saved it. Uh-huh. Let's make an easy one. Okay. Oops. Clear. Okay, so I have my CSR.pem. I have my key. Now we're going to use that key to sign our cert. Okay. Okay, so the last part three is OpenSSL X509 dot require dot days 1 2 3 4 9 dot in use the CSR file dot pem dot sign key, and we're going to use the key.pem, and then what's going to come out is going to be called cert.pem. Okay, everything's going well. The certificate has been self-signed. Awesome. All right, and go ahead and remove that key CSR.pem. Cool. Next part. Let's see. Let's double check our code. Okay. So that good. Okay, package.json. Mm -hmm. So, oops. So right here, we're gonna have to change this, right? That is an error. Sure. Okay. Go and save it. Not sure why it's saved like that. Because it'll CSR, then okay. And let's go ahead and run it. My npm start. How was it? Start. Oh no, npm run. I'm getting confused. Start that. Don't worry. This is just not defined. Little errors like this. Don't worry. Because I forgot to change this. Little mistakes, I say. Okay, hopefully that works. Awesome. It's running. That's how I know it's going. Let's go ahead and go to our Firefox. I think the most time consuming is just waiting for Firefox to load. After this, I gotta go turn in my laptop. So that's why the Node.js tutorial is fast. Okay, there you go. Let's go ahead and get to HTTPS colon slash, oops, no, slash slash local host. And oh no. Oh, silly me. We're supposed to put the socket. Try again. There you go. Get my hopes up. I mean, it's running, but it's an issue. No, it's running. Node.js. npm start. Must be something with my Firefox. Go ahead and start this again. PS. What is the socket number on it? 8080. Okay. Let's go ahead and go here. HTTPS. Top local host 8080. Mm-hmm. Everything's working, but let's go ahead and clear this out. Oh, close it. Close that. All right. Let's see. Go ahead and just add this. I'm gonna change it to port 111. For some reason that. Okay. Good. I know why I opened Thunderbird. Okay. Go ahead and do this. HTTPS. All right. There you go. I guess port 8080 is not giving me a good connection. So let's go ahead and continue. Oops. Oh my gosh, Thunderbird just opened up. Ignore Thunderbird, please. Go to events. Self-signed certificate. Accept the risk. Not safe, but it is a tutorial. So, all right. There you go. I access my local host, HTTPS, with socket 111. Let's go ahead and check our cert. So go over here. Your certificate. Look at that. Beautiful. Oh, I should have changed some of the name, but it's okay. RSS. Yep. All looks good. All right. Thank you for following along. I know that was long, tedious. Most of them are pretty simple, but others aren't. I think my favorite one was Windows ISS, second Apache, and my least favorite was Node.js. But thank you for watching. Stay tuned for next.
Hi, my name is Ryan Trin, and in this demonstration I'll be showing you the VPN that I set up using OpenVPN. I'll walk you through how the VPN server and the client connect securely, what tools and configurations were used, and also demonstrate the VPN in action. So what is a VPN? A VPN is a virtual private network. It creates secure encrypted tunnels between your device and a remote server. Oftentimes, VPNs are used to protect privacy and data on public networks, bypass geo-restrictions and censorship, and lastly, secure remote access to internal company networks. I used OpenVPN as the main VPN solution and EasyRSA to generate the necessary certificates and keys for the server and client. I'm hosting both the server and client on the same network for demonstration purposes. And I'm using my WSL environment on Windows and a Windows OpenVPN client. So as you can see here, this is just a brief photo of the connection being successful between the client and the server. And this is from the GUI interface provided by OpenVPN. For the server, I configured OpenVPN with the UDP protocol 1194. I generated the CA server key and client certificate using RSA. Specifically for the client, I created an OVPN config file that includes the CA, client cert key, and TLS key, and I used my own internal IP address to ensure the client could connect to the server from the same network. I used the cipher AES-256 and auth is SHA-512, and this is mainly because it's just an industry standard encryption. And lastly, I had TLS auth, which helped to add an additional layer of packet authentication. So here are some of the challenges that I faced during the setup process of the VPN. I was mainly having issues with the TLS handshake failures, and this was caused because the client couldn't negotiate encryption due to the connection or certificate issues. I fixed this by using the internal IP address of the VPN server during testing on the same LAN network. Another issue that I commonly had was the cipher mismatch warnings, and this was because OpenVPN's versions 2.6 plus ignores the dash dash cipher without specifying dash dash data ciphers. So I fixed this by adding data ciphers AES 256 to both the client and server configurations. And now I'll do a brief demonstration to show you. So here is the network live. This is a live real-time connectivity of the network right now. And I'll just show you, I'll connect to it right now. Here's the GUI interface, and here it says connected to the client 1, and it shows the assigned IP address. We can also view and show statuses here, and we can also see the bytes in and bytes out. And yeah, that's just a demo of the presentation. Thank you very much.
Everyone, today I will walk you through how to set up and configure an SSH server that allows secure passwordless login using SSH. So like you see, I'm using the Ubuntu to set up my SSH server, and right now I try to log in that by the command. And you can tell I can log in it right away without typing the password. So to set it up, I use the command sudo apt update. So make sure everything is updated on time. And then it will do this one. So I use the sudo apt install open SSH server. And I use this one to start. So I use the sudo systemctl status SSXD to see how it's active or not. And you can see right here it's like active running. And I use the CF UFW allow SSX to configure the firewall because the server is listed on the port 22, and after that on the Lion machine I use this one to make the key for me, the private one and public one, by this command ssh keygen dash t and ed 25519, and see it's my email. Like you can see on my screen, I try to enter the passphrase, but somehow I cannot do that. So I just enter and enter to keep it. I know it's if I set up that's more secure for me. And this one is the successful when it react the key. So, and I try to log in that. So when I log in, it didn't ask me to use the key anymore. No, it didn't ask me to use the password anymore. And this one, how I can find my key. So I use the CD and this command to go inside of that folder. You just want to show how many key I have. So to see the key, I use this command to get it. This one is my public key. So the one thing I forgot to mention, I use this command to install the public key on the server. So this ensure only my machine can access the server. I chose ED25519 because it's more secure and faster than RSA. I disable password login to prevent the brute force attack. Um, so for solution, I think it will be have like stronger security with no more password store or tie when I log in into the server, and it's more convenient. It's faster and easier access to remote server. And the one thing I challenge me, like if someone get my private key, they do not need to use the passphrase. So that I wanna do in the future for my server, so I can like add passphrase on that. Thank you and have a good day.
Hello everyone, my name is Daniel and I'll be trying to set up, not OSPF, we're gonna do that as well, but we're gonna try setting up um IPSec, okay? Um, 1 second. Okay, so the goal right here is, well, first you're gonna set up the IP address for each of the devices. Go ahead and connect this one to this one. There, I don't think it matters. Go ahead and set up bottom up desktop IP address. Go ahead and put 192.168.1.2, that, then 192.168.1.1. Okay, okay. Go ahead and close that. Go ahead, router. Let's set this up. Let's see. Anytime you're gonna use OSPF and packet tracer, you're gonna have to go to CWIC at 2T, drag the interface, and put it right there. And more serial ports are gonna come out. So, for example, so I don't know if I could hover through it. You only have like 2 serial ports. I don't know if you saw that. There you go. 2 serial ports. Where'd it go? Okay, go ahead and add more. Like, boom. Oh, you always have to turn it off when you're gonna add. So 1, 2. Oops. Let's turn it back on. Turn it back on. Okay. Close this. See how many? There you go. I got more serial ports and excessive, but it'll be just fine. Go ahead, put no. Um, enable it. Big, big E. Okay. With the host name to host name CCUS. Okay. And let's give it, where am I? Int 0/0. Go ahead and give it an IP address. 192.168.1.1. Don't forget the subnet mask. No shut. X exit. Int s. We're gonna do 0 port. Is 1/0. IP add. No. Should add the IP address for this one. Give me 1 second. Go ahead and add them. Just for 101.101.1.1.0. slash 30. Since we're doing like 2 ports. There you go. That's gonna be dot one. Probably did dot two. And that's gonna be dot two. Not two one. Okay. Go ahead and edit that. Probably had it behind it. Yeah, I did. So yeah. Oh what oh well. Go ahead and continue with our router. So we're adding IP address dot one dot one dot one dot one. And we're gonna put 255.255.255.252. No shut. Okay. Let's go ahead and enable OSPF, might as well. So to enable OSPF, so go to router, OSPF, and then put one, and then you're gonna put your router ID. No, dot, dot, one dot one dot one dot one. We're gonna advertise our network, which is gonna be 192.168.1.0, wildcard mask, 355, area 0, same thing for the top one, network 101.1.1.0, 0.0.0, and since we're using slash 30, it's going to be 3, our wildcard mask. Okay, let me double check something real quick. Yes. Um, So don't forget and add a default route, just in case. Hang on. 101 dot one dot one dot. Hmm. Okay. Yeah, two. Okay. Go ahead and hit enter. Okay. Mm, hmm. Let's put end. Let's write it. Okay. And go ahead and reload because that's gonna give us issues if we don't. We run with a refreshing it. Well, meanwhile we wait. Let's go ahead and set up router our internet router. Let's go with CLI, enable it, config T, host name, let's put it internet. Okay, let's set up the IP or interface, S0/0/0, IP and 101.1.1.2, 255.255.252. No shut. Awesome. Both serial ports are on. Go ahead and advertise our OSPF. Okay, router, uh, router ID, dot three dot three dot three dot three. Go ahead and advertise our network. Um, I'm gonna have to also do serial port 0, 0, 0, 1. So let's go ahead and do this one first. Dot 0, 0.0.0.3, area 0. Okay. Let me do 102. 102.1.1.0, 0.0.0.3, area 0. Yep. Let's go ahead and exit. Int s 0/0/1 IP and 102.1.1.2, 255.255.255.252. Go ahead and give a no shut. Go ahead, exit, exit. Let's write it. Let's go ahead and reload and see that off right now. Go ahead and close that. So right now, my report is up. The other one is down because they're not connected. Similar to that. Up. The other one is off. Or they're both up, actually. Sorry. Go ahead and do this one right here. So I don't know if you noticed, I'm going up all the way down, setting up my routers and my host, my PCs. Kind of time consuming, but hey, I gotta do it right. Go ahead and start with S0, 0/0/0/0. Okay, and then we're gonna put IP add 102.1.1.1. Dot one. Yep, that's that one. One, 255.255.0, 5.4, no set. Cool, and they're both up. Let's exit. Go ahead and put a interface and G0, 0/0/ no, G0 IP add 192.168.2.1, 255.255.255.0. No shut. Okay, exit. Let's go ahead and give that host name. Now, Ollie, so I know what I'm working with. After we set up the interfaces, let's go ahead and set up OSPF. Router, OSPF 1, router, let's give it an ID, and this one can be 2, and we're gonna advertise our network. Remind me that I have to set up the default route for both internet and Cal Poly. But let's go ahead and finish this. 2.168.2.0, 0.0.0.255.area 0, network 192.168. Oh, no, sorry. Network 102.1.1.0, 0.0.0.0.252. Oh, my bad. Because I did not do it right in there. Go ahead and change that to 30. I mean the correct label, right? Oh, see, there you go. I found my neighbor. 93. I'm gonna give that default route. Exit IP route 0.0.0.0 space 0.0.0.0.102.1.1.2. Okay. Let's go ahead and right. Let's go ahead and reload. Yes. Let's go while we're waiting. Let's go ahead and do internet. I forgot to set up the IP routes for internet. Okay. Enable the big T IP route 192.168.1.0 255.255.255.0 at a it just did not look right. 101.1.1.1. I'm sorry, people. Um, 1.1.1. Cool. Go ahead and do the same thing for, and that was 102.1. Go ahead and that, write it, reload. Okay. Now, I do not remember if I set up the PCs yet, but let's go ahead do that. Desktop IP config 192.168.2.2 255, and my default gateway is oops, 1. There you go. Let's see PT1 IP config. Yep. Set it up. Go ahead and try. Go ahead and 192.168.2.2 into network. Timeout. All right, awesome. So what's going on? From PC1, I'm going through the network, router 1 or CSUF router, going to the internet router, and my Cal Poly. Let me go ahead and change these. So for best practice, I mean, it doesn't really matter, but hey, in a network simulation, gotta be as accurate as possible. Okay, people. Next we're gonna do is set up IPSec. Okay. So we know that it's able to communicate. Now the goal is to have like a site-to-site communication. Usually these are used with VPN. Um, so the steps, I mean, it's not too hard, but one of the issues is packet tracer sometimes gives you errors when, or doesn't give you the option to establish it, which you can. Um, I just don't know why it does that. That's a packet tracer thing. So first thing we're gonna do, we're gonna go to router 1, and we're gonna select crypto or type in crypto, ISAKMT. Then we're gonna get a policy number, policy 1, and it's doing it again. I was just having this issue earlier. Luckily, I have yeah. So I don't know why it's not doing it. Hmm. Let's go ahead and reload it real quick. Maybe a reload will work. All right, that's it. Short end. Make sure we write. Reload. I know it's reloading, but let's try doing this as well. Go ahead and turn it off. Turn it back on. That's why I write it, because I wanted to save it to the startup config, not just the runtime. Because when it's just on runtime, when you turn it off, everything goes away. So it's just a RAM. Um, and I stored it into VRAM and DRAM. Okay. See if it works. Config T. Crypto. Crypto. ISAKMP. Policy 1. Hmm. C R C R Y CRYPTO ISA policy. What? Hmm. Typing it in correctly and it's not working. Give it a minute. Hmm. Go ahead and see this. Yeah, it should be in config T. It could be CRYPTO. Hmm. What was it? Give me a second. I was able to get it running earlier. For some reason, it's not working. Let's try this one. License, root, module, C2900, technology package, security key 9. Go ahead and and write, reload. Okay. Luckily, I only have to do for 2 routers, not all 3. Enable, config T, crypto, um, crypto, IA. If it loads, ISA policy. What? Um, Path tracer thing. Hmm. Let's see if I still get a ping. Oh, Control F6. Config T. No. IP. Look up. Oh well. Config T. Hmm. Earlier I was able to do it. Now it's not working. RYPTO. Oh, wait a minute. I think I know why. I think I know why. So the thing is, sometimes you had to enable them for both. It's just when I did it the first time, I did this for both. Module C2900, technology, security 9, good. And oh my gosh, do um, right, reload. Yeah. Enable config key. Okay, config key. All right, let's try this again. Mm, Let's so ISAK crypto ISAK um policy one. We want that key. Try this again. You gotta constantly keep doing this till a little it becomes up. License, boot, module, 82900, technology package, security. Yeah, let's see. There you go. Now I got it. That's the thing about Packet Tracer. I honestly didn't do anything. It just takes a while. Now that one's working. Okay, now we could get started. Well, let's hope it could work. That took forever just to get it working. Okay, now that that's working, we should be able to KMP policy one. Oops, actually, and we're supposed to reload. Um, then IPSec MP policy one. There you go. So once you got that, So you were supposed to put the license boot, and there was supposed to come out a screen that you're supposed to say yes. So when I resetted it, so going back right here, so I didn't change anything. It was just packet tracer being packet tracer. I entered this command, nothing came out. I tried again later. It gives you the licensing right here, and then you're gonna select yes on it. Like, do you set yes? Um, then I'm gonna have to write it and then reload it. So once I reloaded it, it was able to finally give me the option to put crypto ISK ISAKMP. Okay, let's go ahead and continue with our thing or with our IPSec. So we're gonna put encryption, AES, sure. Um, then we're gonna do our hash is SHA SHA 512. Let me see, what does it have? SHA 512. I could possibly just do hmm. Oh, wait one sec. I'm just gonna leave it as SHA. Okay, there we go. And then we're gonna use authenticate pre-share. Okay, pre-share. Go ahead, enter. We're gonna use the group two. We're gonna give it a lifetime. 86,400. That's going to be the default. And we are done with that. Awesome. Mm-hmm. And let's go ahead and do the same thing for this one. Enable config T, uh, crypto map, crypto map, oops, crypto, not crypto map, ISAK MP policy one. There you go. Working now. Encryption, AES. Let's see. Encryption AES. Let's go hash SHA, authenticate pre-share. Go ahead and give a group two. There's a lifetime of 864,000, 4,000. And that's exit. Okay. Once we've done that, let's go ahead and let's give it a key. ISAM, what do we call it? Let's go ahead and go back to 50F. So, alright. So crypto, ISAKMP. Let's give it um, CSUF to Cal Poly, and then we're gonna give it an address. Address of what address was it? So what's the address of the routers? Address. Make sure I give you the right address. One. Okay, I'm assuming that's gonna be the address. Okay, go ahead and give it address of this one right here. Go ahead. 102.1.1.1. Okay, enter. Oh, what did it do wrong? Ah, yes. Don't forget about key. Okay. Or let's do this. VPN 123. Since that's going to be our key, let's keep it consistent. Awesome. All right, let's go ahead and do that with the same thing with route. Or let's finish this first. Um, go ahead and put crypto IPSec transform set on CSEC ESP ESP AES and then ESP SHA and then HMAC. Okay, let's go and give it access list. So IP access list expand IPsec list. Now we're going to give the permit 192.168.1.0.0 oops, .0.0.255. Then we're going to do this 3.2.0.0.0. I'm getting confused with how many zeros. When I do that's that. Yeah. Ah, permit IP. Sorry, people. Awesome. And the thing we're gonna do is do a crypto map. Crypto map. The map one IPsec. IS ISAKMP. Okay, so that's normal. Basically, once I set up the router 2, it should be enabled. Okay, so let's go ahead and set the peer. 102.1.1.1. Okay, the transform set, give it the T set. Let's go ahead and match the address. IPsec list. Basically, specify the actual list of IPsec underscore list. And let's go ahead and let's go ahead and give crypto map to our front or our router's front looking interface. So in this case, we're gonna go to and that's sorry, @0/0/1/0. Let's go ahead and give it a crypto map and give it CMAP. I'm gonna spell it right. Okay, there you go. It's on now. Let's go ahead and do router 2 or Cal Poly. Okay, same thing as last time. Go ahead. We're gonna do. I don't know if I did it right. ISNK MP policy 1. Yep. Let's go ahead and do that. Encrypt and AES. I'm just redoing it again just in case if I did not do it right. Shaw, password Shaw, authenticate, free share. If we forgot, free share, we can give it a lifetime of 864. Not that much. go ahead and go to the next step. Next, we're gonna do crypto, I, crypto, ISAKMP. I think I used VPN 123. VPN 123. Let me double check that. Go over here. Just gave me a bit. Let me see what did I use that P again. Map set. Here it is. Yeah, VPN 123. Okay. Let's go ahead and put address 101.1.1.1. Go. Let's go. IPSec. Transform set. C set. GSP. AES. PHP. ESP.shaw. HMAC. Give me 1 second. Oh, my eyes are getting tired. Okay, where was I? Yeah. And now we're going to do the access list. Access list. And IPSec underscore list. We're going to permit the address. Permit IP 192.168.2.0. 0.0.0.255 192.168.1.0. Now we're gonna do the wildcard mask for this one. So we're gonna allow someone to this one. I permitted my IP and I want to speak to the other one across the network. And it's just vice versa. Everything goes well. Should be able to hit submit. And so map, policy map, 1 IPSec ISKN. Okay, so did I not just set it up? Okay. I believe I did that right over here. Somewhere around here. There it is. Put the map I there. Same over here. Same thing. We're just gonna have to wait till we set up the interface. Okay. So what was that? Router 2. We set up the. Okay, let's go ahead and set the peer. Set peer 101.1.1.1. Set transformation set. P set. Let's go ahead and mask the address. IPsec that list. Okay. And let's go ahead and put the CMAP to that interface, which is, oh, let's see. Okay, so it's going to be serial. So for this one, I use S1 that and be S0. Okay. All right. Okay. Let's go ahead and go to the interface for router 2 int 0/0/0. And then we're going to put crypto map, map. There you go. On. Go ahead and end it. And go ahead and write everything so I don't lose anything. Yeah, go ahead. Go ahead and do the same thing. And go ahead and write it. Okay. Now, go ahead and ping. Ping 192.168.2.2. So basically, I'm going to ping from here all the way to here. It might take some time. Awesome. I got a ping all the way over there. And there is a command that I could check to see if I'm actually getting anything. So in our, okay, oops, sorry. I didn't ping from there. I pinged from here. I'm sorry. Uh, let's go ahead. I mean, I was able to ping from router to router. Awesome. I got something. There you go. Now that I'm pinging, I'm basically sending traffic to here. Go ahead and there's a there's a command that you could. Sorry. There's a command that you could see your crypto traffic. So crypto ISA AMP. There you go. IPSec crypto ISA MQP. It should also be doing it for my router too. So Cal Poly, the same thing. So crypto CRYPTO ISA AMP. Yep, awesome. Hmm. Let's see IPSec. There's also another command that we could try. So, um, crypto IPSec essay. Awesome. Interface. Yep, here. So I am getting local identity right there to remote. Packet encapsulate 7. Go. Local crypto endpoint 102.1. And I think there's a way that you could use a GUI for it, but let's see. Actually, I do want to try something else just to make sure that we have everything going as smooth. Go ahead and set up a server on this IP. Go ahead and connect it. Internet 1. Go ahead and Internet 2. We'll go ahead and open it. Let's go ahead and let's turn off HTTP. Let's give an IP address. Yes, interface at 0. This is going to be 192.168.2. And then give it an address. Let's give it that 3. That service desktop. 192.168.1. 2.1. Okay. Everything looks well. I should be able to ping it. Go ahead. What was it? I think it was that 3. Go ahead. That's that 3. Okay. All right. Go ahead and ping it. Ping 192.168.2.3. It's gonna be a while. It's going through the Network. Awesome. I got a connection. Let's try this. HTTPS at 92.168.2.3. Oh, sorry. It's supposed to be not command prompt here. Web browser. If that doesn't work, there's only one last thing we could try. HTTPS. Got that. 192.168.2.3. Awesome. I'm getting it open. Let's see what else is there. There's also doing that. Hello world. Let's try that. Actually, disregard that. I did get packet picture going. Go ahead and see the image. Oh, gain access to that web browser. Ah, here it is. Hello world. Cool, cool, cool. Let's see. All right, let me go ahead and save this. Let's see, edu, yeah, packet tracer. All right, close this, and go and try that again. So be able to send right there. Oh, sorry, I didn't send anything. HTTP 192.168.2.3. There we go. Sending. That was real neat. I didn't know packet tracer could do that. Okay. Awesome. Look at that. All right. Doesn't explain why it's going slow. But let's see. Hmm. All right, we can pause that. Let's see. IP header. Cool. Ah, yes. It's going to be impound edu. Now, example, destination address, IP, TLS, source, 5, checksum, secret number. Nice. Awesome. IPSec PDU. Let's see. All right, let me go ahead and pause this. Okay, I finally figured out how to see if how to see IP headers or IPsec header. So you need to know a little bit about networking. So when there's IPsec, um, there's gonna be I say it, there's gonna be an added layer in that PDU, and that's called ESP header, which has like the data encrypt, the data authentication, and then the data itself, which is used for IPv4. I believe version 6 has it already, but since everything is IPv4, be good. Now, if you're looking at my screen, you can see simulation mode is sending packet over here. Let me go right here. It goes to the switch, and it should go to that PC server. Go ahead and see that visible or not visible. Go to the inbound. That's not the one. Go ahead. Let me pause this real quick. PC1. Now it's going away. Inbound. This is PC1. Where is here it is. CSUF. Inbound. I just had it right now. Not this one. Poly? There it is. It's Cat Poly that has it. Just sending it back. So here it is. HCLC is the IP. This is the inbound. See, outbound has it. Oh, outbound also has it too. So this is how you prove that that you're using IPSec. Because you have ESP. I don't know what that is. You brush on my CCNA knowledge. Sequence number. Data encrypt was 4. Data authentication was 2. And that. Now I'm sorry this video took too long. But I was going the same. I was learning the same time as trying that. But I want to thank everyone who stayed tuned and watched it. I know this was a long video, but it was great learning how to do IPsec in this in Packet Tracer. All right, thank you for watching and have a great semester. Bye. Yes.
Question number 5. Set up an email account that's use pretty good privacy for security. Introduction. Pretty good privacy is a widely used email encryption programs that ensure confidential integrity and authenticity of email messages. Step 1. Key generation is done before emailing. At least generate a PGP key pair, at least public key share to everyone. Second, at least private key keep secret for her. Next, Bob also generate his own PGP key pair, Bob public key and Bob private key. The public keys are used to encrypt messages, and the private key are used to decrypt and sign. Step 2. Alice sends an encrypted and signed email to Bob. First, Bob gives Alice his public key via email or key server. Second, Alice writes her message. Hi Bob, here's your secret file. Then Alice do two things. Encrypt the message using Bob's public key. Only Bob's private key can decrypt it. Then she shared the message with using Alice's private key, so Bob can verify it's really from Alice using Alice's public key. Then Alice attached her public key to message. If Bob doesn't have it she have to send the private another email to Bob. That email attached the public key. Finally, Alice sent the encrypted side email to Bob. At the final step, step 3, Bob received and read the email. First, Bob received Alice's email, which includes the encrypted message, Alice's digital signature, Alice's public key. Then Bob decrypted the message using his private key. Then Bob verified the signature using Alice's public key. Finally, he got the proof the message is really from Alice, and it also confirmed the message it hasn't been tampered with. On my screens is Bob email. I create Bob email from myyahoo.com. Now, first of all, I need to create a BGP key for Bob. I go setting, account setting, and to an encryption. I add a key. I create a new key. The key will expire in 3 years. The key type RSA. The size is 3072. I hit confirm. I create my key here, Bob key. I not gonna to publish the key because I only contact with Alice, so I don't need to do that. Now I go to email. I hit a new message. I send to Alice. The subject. I try to encrypt the message. Then I send to Alice. Alice, can you read my encrypted message? Oh. Then I hit encrypt and sign it. I cannot send the message because I cannot encrypt it with Alice's public key. I hit send. It shows me error because I cannot encrypt with Alice's public key because I don't have Alice's public key. So this is not correct way to do. So now it said the key was not found. Now I gonna to send Alice my public key before I encrypt the message. Public key. This is my public keys, Bob. So I attach my public key. The email will automatically add in attach public key at the bottom. So I successfully to send my public key to Alice. Now I am on Alice's email. Waiting for Bob public key. In the meantime, I create a BGP key for Alice. I need to do the same step because I have the old key, so I delete it. Now I add the new key. I delete the old key. Okay. I add the new key. Continue. I choose a key and confirm. I don't publish my key. Here's my key. I'm not received email from Bob yet. Now I send Bob my public key. I type email Bob. subject, Alice public key. I send him my public key so he can send encrypted message to me. I attach my public key and I hit send. The email automatically add public key. I check my email again. I check email again. Now I got Bob public key right here. I gonna to import Bob public key into my email system. Import is okay. Now I check it again. Here's the Bob public key, my key and Bob public key. So I'm gonna to encrypt the message by Bob public key. Encrypted message. Hi Bob, can you read message? Encrypted message. I encrypt and sign. I hit send. Now I'm going to Bob email to check this email. Now I'm on Bob email. I see encrypted message from Alice. This is mail encrypted. You will see the icon on the right hand side, the lock, and I'm gonna import Alice public key. Save it and import. I verify my email. Yeah, I have Alice public key right here. Okay. I'm going to send Alice encrypted message. This is message encrypted by Alice public key. I confirm that. I can confirm now that Bob and Alice messages are secured by BGP public key private key system. I hit send. Now I come back to Alice's email to check the message from Bob. Yeah, I got his message, encrypted message. I check, I see the signature, digital signature. I confirm yes, I verify this email from him. And we see the blue green check mark, mean the message is encrypted and verified inside. That's it for PCB encryption message. Question 6. Introduction. DNSSEC. This stands for DNS Security Extensions. Its function is as cryptographic signatures to DNS records and verifies data integrity and authenticity and prevents cache poisoning, MITM attacks, and forged records. Finally, it can work through digital signatures and public key. How DNSSEC works. First, each resolver requests DNS record with do DNSSEC OK flag. Second, authoritative server respond with original record signature public key. Finally, resolver verifies signature using DNS key. Configuration. In this configuration, I use server Ubuntu server. IP address is 192.168.64.14. On client, I use Ubuntu. IP address is 192.168.64.15. Now we move on demo to see how DNSSEC work. Let's start on the server first. I check the status of DNS security to see the status. Right now it loaded enable and the status active is running. Yeah, it's running. Everything is good now. Next, I check IP address to make sure I am on server. Now I check my domain, the query of DNS key. Next, the record of lido.com. I open up the Wireshark to see the transaction on my computer network. Now we then we move on the client Ubuntu. Here is the transaction of the Wireshark. The IP address 64.14 is server, 64.15 is client. Now we move on client. This is on Ubuntu client. I check my IP address is 64.15. Now I send the DNS query to the server. Then I show the current DNS configuration. I set the Lido.com. This command for showing current DNS configuration. And then I send a DNS query to the default DNS server configured on your system, asking for lido.com a record with DNS security data. Then I come back the server to see how we capture on the Wireshark. I'm going to do the filter on Wireshark on the server. Here's the meaning of each number. DNS43 means delegation single connect the child zone DNS key to the parent zone. RRSIG46 resource record signature hold the digital signature for a DNS record. Validate that the data hasn't been tampered with. And SEC47 next secure with the next name in DNS zone using navigate respond to rule a record doesn't exist. DNS key 48 is DNS public key and SEC3 number 50 hash and security. Finally, NS EC3 param 51 is NSEC3 parameter tell resolver how to interpret NSEC3 hash algorithm solve interaction. Need to validate navigate answer using NSEC3. Now I'm going to opening Wireshark. This is Wireshark on the server. I go ahead to filter. we base the filter is all transaction with DNS and DNS. Now we finish the demo for DNS security. Thank you for watching. Kerberos server client authentication protocol widely used on Windows and Unix-based networks enables authenticated user to securely and seamlessly use multiple network services with a single logon like email, routing, company portal, or SSH services. Based on the concept of KDC and is based completely on symmetric key cryptographic techniques. My configuration is on server Ubuntu 25 IP address 192.168.64.14 and the client is Ubuntu 2504. IP address is 192.168.64.15 and I also enabling SSH authentication with Kerberos on the server. While setting up Kerberos server and client, I face challenge. Client can reach the server IP like Bing and CTAS work because it sends a short rope. However, full Kerberos tickets request erupt silently by the firewall. My solution is Open UDP ATA Kerberos authentication and Open TCP ATA Kerberos for back for large messages. Just open the port for the firewall. Now we go to demo. Hello everyone, today I will be presenting a demo of Kerberos server highlighting the following features: displaying the Kerberos status on Ubuntu server to prove that I successfully installed Kerberos on server. Second, I enable SSH authentication with Kerberos on the server. Third, I create a Kerberos user and a Ubuntu server. Then I start on client. Now on screen is show that Kerberos server is active and running. Next, I enable SSH authentication with Kerberos on the server. By go to configuration file,
You are talking?
I go to config file and enable the command. Turn them to yes. And do the same for CGS API options. Turn everything to yes. Now I save the file. I restart SSH. And check the server again. Next, I restore the Kerberos server and check the status again, make sure everything ready. Now I add the user for Kerberos. I type a command to enter Kerberos command like sudo kadmin.local @vinci klidu as my username, and then I typed the password. Then I re-enter the passwords. Now I create the user on the Kerberos. Now I create the account on Ubuntu server. We should be the pair of account like Ubuntu account and Kerberos account. This is not necessarily the same password, so I create all for my own passwords. I finish everything on the server. Now I go to the client, Kerberos. This is the client Ubuntu. I set up two different virtual machines. This is on client. I init klidu account. Then I input the password. Make sure input the password of Kerberos. Then I connect to SSH. It automatically logging to the SSH. I don't need to type the password again. Now it's proof that I successfully log into Kerberos server and SSH on the server. Thank you for watching.